Hello everybody, welcome to the IT Skills channel. In this video, we're going to continue our AI-102 series, and this is going to be an important video because it's going to help you hopefully pass your certification exam, the AI engineer certification. And without further ado, we're going to get started. But before we do, I want you guys to subscribe to the channel, hit the like button if you like this type of video. We spent a lot of time getting this video ready for you guys. It's not easy putting all this together, especially the key knowledge test, key discussion points, and so on. So without further ado, we're gonna get started. And also, if you can consider being a member, please, be a member of the channel so we can bring you exclusive content. Without further ado, we're gonna hand over to our presenter. Until next time, we'll see you later. And subscribe if you haven't already, please.
Welcome to I Teach Skills. I'm your instructor Ali. Welcome to our journey into creating language understanding solutions. Think of it as teaching a computer to understand human conversation. Just like learning a new language involves grasping vocabulary and grammar, building these solutions requires us to teach machines how to interpret words and context effectively. Building on that, let's dive into the agenda for creating a language understanding app. Think of it as piecing together a complex puzzle where each part is crucial to the whole picture. First, we explore how to design and develop such an app, focusing on what makes it understand human language effectively. Moving forward, once your app is ready, you'll want to share it with the world. This involves publishing your creation. Finally, let's consider how users can engage with and utilize this tool in their daily lives. Imagine building an app that understands human language as if it were a super smart friend who knows exactly what you're talking about. This is where natural language processing (NLP) comes into play, allowing the app to interpret and respond appropriately to your words. Let's explore how we can construct this linguistic bridge between humans and machines by first designing the architecture that processes. Imagine building an app that understands human language as if it were a super smart friend who knows exactly what you're talking about. This is where natural language processing (NLP) comes into play, allowing the app to interpret and respond appropriately to your words. Let's explore how we can construct this linguistic bridge between humans and machines by first designing the architecture that processes spoken or written inputs. Natural language processing, or NLP, involves teaching computers to understand human language, similar to learning a foreign language from scratch. At its core lies natural language understanding, NLU, which is like deciphering the intent behind someone's words. Think of it this way: an app first listens to what you say, topic, user input, then uses a language model as a wise translator to figure out your actual meaning or intention, topic, semantic meaning. Finally, based on this understanding, the app acts accordingly, akin to carrying out someone's request. This entire process allows technology to interact with us more naturally and effectively. Let's delve into intent and utterances, key components in training language models. Think of utterances as specific phrases like, "What time is it?" or "Turn the light on." These map to intents such as "get time" or "turn on device," assigning meaning behind each phrase. By specifying these mappings, we create a bridge between natural language inputs and their intended actions. Entities bring context to what users mean by their utterances, much like giving clues in a treasure hunt. Think of it this way: when you ask, "What is the time?" your intent is to get the current time, but if you say, "What time is it in London?" adding the entity of location, the London, narrows down the answer specifically to that city. Now let's explore how entities can shape our interactions by identifying not just what we want, but also where and when we are asking about it. Building on that, an utterance like, "Will I need an umbrella tonight?" uses both get weather as its intent and adds time, tonight, as an entity to refine the response. Entities don't always stick to predefined lists, sometimes they are learned through examples or defined by common types like numbers. Think of prebuilt entity component as a smart assistant that quickly identifies and categorizes information in your chat conversations. These components automatically predict common types such as quantities, like age, numbers, percentages, or currency, and other elements like dates, emails, phone numbers, and URLs. By recognizing these patterns, they streamline data extraction from user inputs effortlessly. To build an effective NLP application, we follow 4 key stages: training, testing, publishing, and reviewing. First, topic. Training involves teaching the model to recognize intents and entities from sample phrases. Think of it like a student learning vocabulary from flashcards. Next is topic. Testing, where you either interactively or through datasets evaluate how well the model understands those learned patterns, similar to a pop quiz in class. Moving forward, topic. Publishing is about making your trained model available online for applications to use, akin to publishing a textbook for students. Finally, topic. Reviewing focuses on refining predictions by examining results and updating training data as necessary. It's like revisiting study notes to improve performance in future exams. Let's dive into creating a language understanding app. First, think of intents as goals or actions you want the user to achieve through their queries. Topic. Intents. Next, entities are like puzzle pieces that give more detail and context to those intents. Building on that, once your model is designed with these components, it's essential to test and refine it before publishing. Lastly, you'll be able to query this model directly from a client app, making it interactive for users. Imagine publishing an app is like opening your bakery to the public. It's where all your hard work becomes accessible to everyone. Once your language understanding app is out there, think of its use as how people come in and interact with your baked goods, each interaction helping you refine what you offer. Now let's explore the process of publishing this app, from testing locally to deploying on a cloud platform, each step ensuring it performs well for users worldwide. Building on that, utilizing analytics tools can be like keeping track of which pastries are most popular, providing insights into how your app is being used and where improvements could be made. Let's explore the dual categories of language service capabilities. First, we have pre-configured features, which are like ready-to-use tools you can employ without any setup. Think of them as plug-and-play elements. On the other hand, learned features need a bit more effort. They require labeling, training, and deploying to harness their full potential. Examples include summarization and conversational language understanding. Moving forward, there's named entity recognition, both standard and custom, which acts like identifying names in a crowd at a party. Then we delve into PII detection, safeguarding sensitive information akin to a security guard. Custom text classification and key phrase detection help you sort your thoughts neatly, much like organizing books on shelves by genre. Lastly, question answering and sentiment analysis give insights into what people are saying and feeling. Think of it as deciphering the mood at a gathering. And rounding out our toolkit is language detection, which is like being multilingual without leaving home. Processing predictions involves analyzing a query, like what's the time in Edinburgh, and determining its top intent such as get time. The system evaluates various possible intents along with their confidence scores, identifying relevant entities like location to provide accurate responses. This allows for precise actions or requests based on the user's input. Think of it this way: building a language understanding client application is like crafting a translator who understands your unique dialect. Using the SDK to submit an utterance is akin to sending a message through a special communication channel where your words are carefully analyzed and translated into actionable insights by processing the resulting prediction. Imagine your language understanding model as a guest in an exclusive resort, the container. Start by downloading this guest list, the container image, from Azure's repository. Next, check them into the resort with necessary details like the resource endpoint for billing and your prediction key. Don't forget to accept the EULA, akin to signing an entry agreement. Once checked in, use this model to predict intents just as a concierge would assist visitors by directing queries. All usage metrics are recorded at the main office, your Azure resource, to ensure everything is built correctly. In practical terms, download the specific container image for the feature you want from Azure Cognitive Services. Now launch it on your host with required parameters so that when a client app needs assistance, it can send an utterance and receive predicted intent in return. When building a command like book a flight to Paris, you need to model the city as an topic entity. This allows your app to recognize and handle different cities efficiently. Now, let's explore email detection in commands. The simplest way is to use topic pre-built entity components, which can quickly identify standard formats without extra configuration. Lastly, if you want only the most likely intent from a query, you should utilize the topic top intent parameter, ensuring your system focuses on the primary user request. Imagine you're embarking on a journey through a dense forest. Each tree represents a piece of information in our subject, and as you weave your path, connections between these trees become apparent, forming a vast network of knowledge. Just like navigating the forest requires recognizing patterns among the trees, understanding this content involves seeing how different concepts relate to one another. Welcome to our session on building a question-answering solution. Today, we dive into the world of creating systems that understand and respond to queries. Think of it as teaching a computer to become your personal assistant, able to fetch answers from vast seas of data just like you would search through a library's shelves. Let's start by setting the foundation for a knowledge-based agenda. Think of it as laying down the tracks before you build the train, essential first steps that set everything in motion. Now, consider how publishing becomes your next crucial phase, like putting on a spotlight to showcase what has been meticulously prepared behind the scenes. Finally, using the knowledge base is akin to guiding travelers along their journey with well-marked signposts and maps. Think of a knowledge base as a treasure chest, packed with valuable information and insights. Just like organizing your closet to find clothes easily, a well-structured knowledge base allows you to quickly access the answers you need. Let's explore how creating one is akin to planting a tree. It starts small but grows into an indispensable resource for future reference. Imagine having an extensive library where every book is filled with answers, ready at your fingertips. This is the core idea behind a question-answering system that leverages a vast knowledge base of question and answer pairs, enhanced by natural language understanding. To make this accessible, these systems are often published as REST endpoints, allowing applications to seamlessly consume this wealth of information. Question answering and language understanding might sound similar, but they have distinct purposes. Think of question answering as responding to a specific query with a static answer from a knowledge base. It's like looking up an exact match for your question. On the other hand, language understanding is more dynamic. It interprets user input, identifies intents and entities, allowing client applications to take appropriate actions. Now let's explore how these systems function differently. To create a knowledge base, begin by using the Language Studio portal. First, create a language service Azure resource within your Azure subscription topic, creating a knowledge base. Once that's set up, connect to this resource in Language Studio and start building your new knowledge base. Think of it as setting the foundation for your digital assistant. Now let's explore naming your knowledge base. This is like giving an identity to your AI helper. After that, it's all about filling it up with useful information. You can import from existing FAQ web pages, upload document files, or add predefined chit-chat pairs for more engaging interactions. Finally, create and edit the question and answer pairs in your knowledge base, ensuring everything is polished and ready to assist users effectively. In multi-turn conversations, systems can handle ongoing interactions by adding follow-up prompts. Imagine these prompts as the next chapter in a book that references previous pages. They help keep the context intact. This becomes crucial when dealing with cancellations, where policies may vary depending on whether it's a hotel or flight reservation. For instance, to cancel a flight, simply call 555-123-4567. Think of a knowledge base like a well-organized library where information is stored for easy access. Publishing involves making this resource available to users, ensuring that it's up-to-date and reliable. Once published, using the knowledge base becomes as intuitive as browsing through familiar topics, with features designed to enhance user experience. Let's explore how creating an efficient system of tags and search functions can make retrieval seamless. Imagine you're a chef perfecting your dish. Similarly, test your knowledge base interactively in Language Studio. Inspect results and see confidence scores like testing your creation. This helps tweak and add alternative phrases for improvement. Now let's explore publishing. Once trained, it creates an HTTP REST-based endpoint, much like setting up a restaurant menu for client apps to enjoy. Creating client applications involves interfacing with a REST API. Think of it like sending a letter to an expert and getting back specific advice. Submit questions such as "I want to book a hotel" to the generate answer endpoint. The system finds the best question match, providing answers with details like answer text, confidence score, and source information. Imagine this process as searching for the most relevant FAQ response on a web page. Improving question answering performance involves two key strategies: active learning and synonym creation. Think of it this way: active learning suggests alternatives when multiple questions have similar scores for user input, like a detective finding clues in different places. Implicitly, the system identifies potential alternative phrases and presents them in Language Studio, allowing periodic review and feedback. Explicitly, the service returns multiple possible question matches to users who then select the correct one, using feedback via REST API to refine the system's accuracy. Building on that, creating synonyms for terms with the same meaning helps enhance understanding, like knowing reservation is a synonym for booking. This ensures that even if different words are used, the answers remain accurate and relevant. Bots have become ubiquitous in today's digital world, acting as our personal assistants. Think of them as friendly librarians who help us find the information we need. With the Azure Bot Service, creating a bot is like setting up your own virtual knowledge base. This cloud platform allows you to seamlessly integrate question answering (Q&A) capabilities into your bot, transforming it from a simple conversational tool into an intelligent resource for specific queries. Imagine building your very own smart assistant, like having a knowledgeable body in the digital world. Let's dive into creating a question answering solution. First off, we need to create a knowledge base, which is essentially a treasure chest filled with information that our bot can access to answer questions accurately. Think of it as gathering all your study notes and resources into one place. Now let's explore developing the question answering bot itself. It's like crafting a digital detective who sifts through this treasure trove to solve mysteries posed by users' queries. Creating a knowledge base from an existing FAQ document can streamline customer support significantly. Think of it this way: rather than entering everything manually, you can efficiently import the whole document into a new knowledge base for instant access and updates. Now let's explore enhancing user interaction. Adding multi-turn context to questions in your knowledge base allows deeper engagement, much like having a follow-up conversation after answering an initial query. To enable users to interact with this resource via email, consider creating a bot based on your knowledge base and configuring it specifically for email communication. Welcome to our exploration of conversational AI with a focus on Microsoft Azure Bot Service. Think of it like teaching your computer how to chat just like you or I would, except we're using powerful tools that help bridge the gap between humans and machines. Azure Bot Service provides a platform where developers can build, connect, test, deploy, and manage intelligent bots, turning them into smart assistants across various channels. Starting with the basics, let's think of building a bot as assembling a recipe. You need clear ingredients, which are your goals and requirements for what the bot should do. As we dive into implementing a bot, consider it like programming each step in the recipe to ensure it executes perfectly every time. Imagine a robot as a multifaceted tool, similar to how a Swiss Army knife combines various instruments into one compact design. Each component of a bot serves a specific function, from gathering data to executing tasks. Building on that, we can consider bots as digital assistants programmed to perform repetitive or complex tasks efficiently. Imagine talking to a virtual assistant that responds just like a friend does, using words or actions. These assistants, called bots, use conversational interfaces to interact with you in turns, whether through text, speech, or even visual elements like cards and buttons. Each interaction, like joining a chat or sending a message, is an event in the conversation's flow. Together, these events create a dialogue where the bot remembers what was said before to make multi-turn conversations smooth. These bots can communicate across various platforms such as web chats, emails, or Microsoft Teams. Azure Bot Service is like the backbone of your chatbot journey, providing a cloud-based platform to deliver and integrate your bots seamlessly. Topic: Azure Bot Service. Think of it as the bridge connecting your bot to various channels. Next up, we have the Bot Framework Service, which functions as a critical component within Azure Bot Service. It offers a REST API for managing bot activities, acting like the conductor that ensures all parts of your bot's performance harmonize perfectly. Topic: Bot Framework Service. Moving on, let's dive into the Bot Framework SDK, a treasure trove of tools and libraries designed to simplify end-to-end bot development by abstracting complex REST interfaces. Just imagine it as a Swiss Army knife for developers, making building bots easier than ever. When building a bot with the Bot Framework SDK, you begin by choosing a template. Think of these templates as different starting points on your journey. You have an empty bot that acts like a blank canvas, ready to be painted upon. Then there's the Echo bot, akin to saying hello world in programming. It's your bot's first conversation starter. And for those who want more built-in features right away, the Core bot includes common functionalities such as language understanding integration, which is like giving your bot a basic understanding of human language. Now let's explore the bot application structure. Imagine your bot as a busy receptionist at an office building. That's what the adapter does. It receives activities from various channels through the Bot Framework Service and passes them to the right person or room, which in this case is the bot turn handler. Once there, your bot processes these activities with tools like activity handlers and dialogues, ensuring every message is directed correctly, much like a switchboard operator. Think of activity handlers as diligent postmen, ensuring every message reaches its destination. When a user says hello, the bot responds with a warm welcome via an HTTP post request, updating the conversation to include new members and delivering personalized messages like, "You said hello." Building on that, our bot crafts and sends responses in real time, making each interaction feel personal and dynamic. Imagine building a conversation like constructing a house. The foundation is the dialogue class, which provides the basic structure. Topic: Bot class. Within this framework, we have two main containers, component dialogue and adaptive dialogue, that help manage conversations efficiently. Think of component dialogue as a room with specific features, while adaptive dialogue offers flexible design choices to adapt quickly. Now, let's delve into how these components work together by examining the example where a pizza order is managed using an adaptive dialogue called Pizza Dialogue. This dialogue utilizes a waterfall dialogue setup in steps. Step 1, which prompts for size via choice prompt, and Step 2, which requests toppings through text prompt. It's like having multiple floors in our conversation house, each with its specific purpose, choosing the pizza size first, S, M, L, and then deciding on toppings. For example, if you choose M, it progresses to the next step of entering toppings such as pepperoni. This process is guided by triggers from a recognizer that initiates actions like ordering pizza or canceling based on user intent. Deploying a bot to the Azure Bot Service involves several key steps. First, you'll create Azure resources by registering an app for authentication and provisioning using provided templates with commands like az-adapt-create and az-deployment-group-create. Next, prepare your bot for deployment by creating necessary files for dependencies. Finally, deploy it as a web app, zip the bot files with Azure Bot Prepare Deploy, and configure deployment source using Azure Web App Deployment Source Config Zip. Building on that, understanding these steps ensures a smooth transition from development to live service. Think of building a bot as creating your own digital assistant, just like you'd build a Lego robot. The Microsoft Bot Framework SDK gives you all the tools and instructions to piece it together efficiently. You'll start by setting up your development environment, integrating natural language processing, and then testing your creation for smooth interactions. Think of implementing a bot as building a robot from scratch. First, you need to define its purpose. What tasks will it automate? Then, choose the right tools and platforms to create your bot's architecture. As with any construction project, start by laying out the foundation, identify the necessary data sources and APIs. Building on that, design the user interface to ensure smooth interactions between humans and machines. Now let's explore how these elements come together. Coding is like assembling parts where each line of code acts as a cog in your machine. Finally, test extensively. Your bot's performance can be fine-tuned much like tuning an instrument. When designing a successful bot, one key factor is discoverability. A bot should be intuitive and easy to use, allowing users to resolve their problems with minimal interaction. The smartness of the bot matters, but it's crucial that it operates on devices and platforms that are relevant to the user base. While our integration can enhance functionality, complexity should not impede usability. Effective natural language support and speech capabilities are essential for a smooth user experience. Ultimately, the bot must solve users' issues better than any alternative solutions. Responsible bot development requires adherence to ethical guidelines to ensure trust and safety. Designing conversation flow is akin to crafting a well-orchestrated play, where each character's dialogue propels the story forward. Traditional application processes rely on static screens, similar to reading a book one page at a time. In contrast, dialogue-based design uses conversations like branching paths in a maze, with the main screen as the starting point, guiding users through selecting pizzas and placing orders seamlessly. Designing for interruptions in digital experiences is crucial because users often engage with applications in nonlinear ways. Think of it this way: imagine ordering a pizza online. You can mix and match steps like adding toppings, choosing delivery methods, or checking out at different points, mirroring real-life interruptions. Now let's explore how systems can anticipate and handle these irregular interactions seamlessly. Designing the user experience is like crafting a map for an adventure. You need to choose the right interface elements that guide users seamlessly. Think of text and speech as signposts, rich user controls as tools for interaction, while cards act as informational waypoints with options like "How can I help?" or "I want to order a pizza." Moving on to adaptive interfaces, these are dynamic and adjust based on user behavior, much like how a chameleon changes color. Receipts and audio provide feedback, akin to a journey's end summary or an audible guide. Sign-in forms are gatekeepers, ensuring only the right adventurers enter, while animations add visual flair, making interactions engaging. Suggested actions are like signposts pointing users towards popular destinations. Hero sections draw attention as main attractions, videos immerse like virtual reality experiences, and thumbnails offer glimpses into larger stories. Card carousels allow exploration of multiple items in a streamlined way, similar to flipping through pages in a guidebook. Think of the Bot Framework Composer as a toolbox for building conversational experiences. It allows you to define dialogue flows, setting up a roadmap for how your bot will navigate conversations with users. With this tool, you can create triggers that initiate chat dialogues when specific conditions are met, ensuring seamless interactions. Moreover, it offers built-in support for integrating language understanding, making sure your bot comprehends user inputs effectively. Power Virtual Agents offer a low-code graphical bot designer, allowing you to define conversation flows and create triggers for chat dialogues. This tool integrates seamlessly with other cognitive services. Unlike Bot Framework Composer, it uses different terminology such as topics instead of dialogues and trigger phrases instead of intents. You can test and deploy your bots within the PVA app. Additionally, if there's a task that Power Virtual Agents can't handle, it can integrate with Composer to fill in those gaps. Today, we're diving into the exciting world of building bots using Bot Framework Composer. Think of it as crafting your very own digital assistant. This tool simplifies programming and makes interactions seamless for users. Now let's explore how you can bring your bot to life step by step with this user-friendly interface. Let's explore how to enable conversational customer support via both email and web chat efficiently. To achieve this, creating a single bot that works across both platforms is your best bet. Topic: Chatbot integration. Moving on, when it comes to testing a bot created with a Bot Framework SDK template locally, the ideal tool for you would be the Bot Framework Emulator. Topic: Testing tools. Now let's explore when a waterfall dialog might come in handy. It's particularly useful when you want to guide users through a sequence of steps in order. Topic: Dialog types.